Hi everyone. Yeah. So in the previous session we solved these two problems, right? Max consecutive ones and max consecutives ones variation three. So now one important thing is, let's say you are done with this, you came up with the most optimized version, and then comes the next follow-up question. So which could be like, what if the input is very large and it can't fit on a single machine? So basically a scalable aspect of this problem. So how you solve this is very important for high level like L5 plus those kind of roles, right? So how to so what's the thought process for this, right? So to simplify things, what you can think is think this as a this input as segments, even for the simple input that we were given, right? Let's say we define like segment like every two elements we consider as a segment. We're kind of simulating like in one mission, you can only process these two elements. So let's define some segment length is two. So we'll process two elements at a time. And as you know, right, so it's like we are processing from left to right. So we need to do that in that sequence only. We can't parallelize this. So just before going to this scalability aspect, right, you just go through the previous session once to see how this algorithm works, right? So basically, we are from the right side, we are expanding the queue, and from the left side, we are shrinking the queue. That's a basic operation we did. You can just go through this. So first, it's if it's a single, just like first element one comes and then this one, we keep on incrementing right side because there is one second element to be incremented, and then zero comes. So when zero comes, what we are doing is we are shrinking the queue. So we shrink the queue. So we uh, completely let go of this whatever we stored now, and we are processing a new queue. So that would be like current index plus 1 pointer. So whatever is there, we are starting a fresh. So this is what we did for like uh, where the input fits in a single machine. Now, when segment length is two, we can process only two elements at a time, right? So how we can solve this? So first segment one is 1 comma 1. Keep track of current length and max length. So we'll process this, right? We'll process this and we can put both of these elements first. We'll put in a queue. So current length is 1. And again 1 comma 1 we can put it. So max length in this case current length is 2. Length is just the length equal to, and max length is also 2. Now we're done with this segment. Right? Okay, let's call it segment 0. Now segment 1 comes. And we have 0, 0, 1. So what we do in this case, right? So we encountered a 0, right? So we can't like we can't uh, proceed further with this queue. Basically, we need to shrink the queue, and we know that we won't be caring about previous elements, right? We're just resetting the queue again. So no need of even checking the previous segment. We can just start a new segment here, which is 1. So we'll ignore this and we'll start a 1 here. So length equal to 1 in this case. And max length anyway is still 2, right? And we are done with this. And the last segment is 1 comma 1. So now when we're processing this, there is uh, there is this carryover, right? This carryover length also we need to pass because there's one here. So that also should be input. So the carryover of the previous segment, right? And we need to carry over of ones, right? So for this, it's a carryover of 2. Carryover is carryover length. It's still continuing, but since we got a 0 here, so it's of no use. We had to reset this. And for this segment, previous carryover length is 1, right? Now we process this. So we increment this again, and length now will be 2 because there is a carryover, right? We need to add that. And again, next element we process because it's 1 again, length equal to 3. So which is max length also. Max length is 3. Yeah, we are done with this input. So this is how you can visualize this, define some, break this input into parts and try to solve each part and then combine that. So since the nature of this problem is sequential, like we are processing from left to right, we can't do parallelization here. Yeah, we need to do from left to right. And now we'll come to the second one. This one, if you remember, right, there is a constraint where there is a k we define, and based on that k only, we are kind of seeing how to. We have a like budget basically, k number of times we can flip. So we can just go through this logic. Is we already discussed this. I'll just define the scalability aspect, right? What if input doesn't fit on a single machine? Same thing will go. It is slightly trickier than the previous one. Let's see how to solve this. First, basic version, right? Without any scalability, you can just see first one is there, and we keep on incrementing q on the right side. First one comes, 1, 1, 3 ones, and then a 0 comes, and then we can decrement k. We had to, so we can decrement 1, and we can still go on right side. And again, we incremented by 1 more 0, and k is 0 now. Still, we can include that in the queue, and the max length at this point is 5. Now again a 0 comes. Now it expands our budget, right? Now k, we can't reduce k any further. So now it's a time to shrink the queue from the left side. So we keep on decrementing this till we hit a 0. So basically we are kind of removing all these elements. And we have a 0, right? And then we are adding whatever the current 0 at this point. So this is how we did. Keep on incrementing from right side, and from the left side, right? You shrink whenever you ran out of the budget of case. So now what if this is like this doesn't fit in a single machine, right? So in our approach will try to define some segment length. In this case, let's say I define segment length of 3. Let's define this. And now segment 1. Let's see what we need to solve this problem, right? 1 comma 1 comma 1. And if you see this queue, its first element is 1, second element is 1 comma 1. It's still incrementing the queue and still incrementing the queue. So we need to have a global queue. We need to keep on passing a global queue. Let's say k only, k, right? K equal to 2 also we need to pass. Now length equal to 3, max length equal to 3 for this segment. Segment is 0 now. Now segment 1, let's see how we can solve this. Segment 1 is all 3 zeros. We still have k equal to 2, right? And now we need to uh, pass the carryover, right? Carryover to 3. Carryover length is basically the length was what was coming from the previous segment. And we add this 0, length equal to 4, and add again 1 more 0, length equal to 5. And now this 0 comes, right? So now it's a time to shrink the queue because we ran out of k here will be 1 and k here will be 0. So we need to shrink the queue from the left side. But this is gets interesting, right? So the queue left side doesn't line this segment. It is there in the previous segment, and we need to capture that also. So we need to have a global variable which says uh, left pointer segment number, right? Which segment is that? And left pointer index in the segment. So it could be previous, it could be like n minus 2, n minus 3. It can be anywhere, that left pointer, right? Because there could be continuous ones and it could be anywhere. So we need to keep track of that left pointer segment number. And there, from there only, we need to string the queue, right? And that is what we need to do here, right? So in this case, segment currently is 0 segment, right? So we need to delete from that. You go ahead and delete from the segment star. So index also is 0. Here initially it's 0, 0, right? Just try to follow this carefully, so it gets a little bit trickier here. So this is segment 0. So here we are shrinking the queue. And so we'll do this again, this first segment, right? Segment 0. We keep on incrementing this, and there is no 0, so we run out of this, and this shrinking process will continue to next segment 1. This is segment 0, sorry. And we again do that. So what we do, we still delete this 0, and then this 0 is deleted now. All right, and that means now that, yeah. So now left pointer will become, so left pointer, so left pointer segment now will be equal to 1, and index is what is the index now? So if you see here, right, we deleted 1, 1, 0 here, right? Our current index is this 0, right? So we need to delete this 0, and our new left pointer will become this this middle 0, right? And that's about it actually. Right, set index to 1, and our new key will become 0, 0, right? And now we process segment to 0, 0, 0, 3 ones. Carry over length is 2. So now this is straightforward, right? All we're just incrementing all of them. So I'll just go to the last element. At the last element, we have in the queue 0, 0, 1. So like in the queue, yeah, this will have it. But so I mean length is 5, right? And max length also is 5. Right, and now we'll go to the segment 3, which is just 1 and 0. Yeah, 1 and 0. Now we again expand this, so the queue become 1. max length becomes 6. Again, a 0 comes, so it won't fit into, we are out of case. So for last 0, we can again, shrinking process becomes, shrinking process starts. Now what is this, this left pointer segment and right pointer index, right? This is left pointer, and left pointer segment is 1 and index is 1. So you just remove 1, 0, right? And now the queue becomes 0, 1, 1, 1, 0, 1, 1, and add the current 0, current index. Again, anyway, length, max length is again 6. Yeah, I hope this is clear. Just go through once. This example is good enough, and just reason through this. So usually no need to write this code. It just we need to explain if the time is there. So usually when this task be like little time left, we can just uh, like explain this briefly. So this is a crucial thing, like divide the input by segment and assume that it's that that part of the input for like is solved in one machine. So we have only that much of RAM, and then you can like it will be like normal DSA problem. It will can break down. And this can even go further, like it can even go into a HLD kind of problem, like how can we solve that? But usually that much time won't be there. Like if it's really on a different machine and if you does it right, this entire thing will be sitting on a node and all statements. So how will you like pass that? How will you route this carryover line? So all these kind of things can span into like kind of HLD kind of problem also. But hopefully it won't go that far because uh, by the time you did this coding and optimize this, there will be little like 5 or 10 minutes left. So good enough if it was off. Yeah, yeah. Thanks.